Okay, so by now you should the pressures of the mind. Do you know the pressure? Do you know the pressure which will do here? And if you do, that would do here. 0 to 10. You can actually 0 to 10. You can actually just add to get to these numbers come from these numbers come here right now. ATM is good pressure. That is before your pressure before you're going for this and the last one, would also so that is that's a hurdle insert and very important so that's a kind of trouble with those so having trouble with those two gases going into 1 meter going into shouldn't that change today now both gases have a 3.5. Both gases have a 3.5 ATM pressure. The answer to that is no. Helium still has 1.5 ATM. 1.5 ATM. And argon 0. That has not changed. Both of those pressures together. But when you put both of those pressures together, they add up pressure. The entire system. Number of entire system is 3.5 just by itself. So the pressure, volume, pressure, the first question is what is an ideal gas? And so we want to be able to hear the pressure, and so pressure, the idea here is number one to be able to measure the best way to pressure is the best way to that was gas. That was the best way to as I'm reading this. As I'm reading ideal gas is oxygen side. Green here is the most abundant pressure is what I'm trying to abundant element air element in which air moles the air convert 12 is nitrogen. You should know this right now. It is second most and then oxygen. And second most is oxygen. Third most oxygen. Kelvin is third most. And so right now, I need to solve this problem straight in for oxygen. So we could know volume of the we could know volume of the So you already have that written down. So you already have that written. Next question. So you already have that written down. Next question is really. And so I'm actually going to give pressure. So I'm actually going to give all Dalton's law is that 1 minute. The combined pressure of all law is that if the combined pressure of all the combined pressure of all the gases in the room, you'll get the total pressure in the room. You'll get the gas. You'll get the total pressure of the gas of all the gas inside. Well, what is partial pressure? What does that? Well, what is partial pressure? Well, what is partial pressure? What does that here? Switch colors here. Colors here. Partial pressure. Okay, so this little subscript's going to try. So this is the pressure. So this is the pressure of oxygen. So the next one you're really going to single. So the next one you're really going to be doing single. So start to wrap up this. Start to wrap up this conversation. So start to wrap up this conversation. So there are probably plenty of questions. Really, there are probably plenty of what that means is that what that means is that here has all that. So what this situation is, so it actually doesn't. So it actually doesn't adjust to focus to just to it's going to be it's just like the idea that we talked about, the idea that we think about all of these starts, the idea that we're thinking about pressure so this was always when there was a change, some sort of change. This was some sort of change to the system. Another color, some sort of change. Well, now we're not now we're talking about this. Now we're talking about pressure of volume. Now we're talking about this rubber balls there. Pressure of volume. We actually haven't both to both, but this equation. What if I want to talk about? What if I want to talk about? One if I want to talk about? But I know the pressure. But I know the pressure. I know the volume. Number of moles. But I know R moles. This would be saying can I find both of those? This would be saying for the pressure and the answer 118 for this pressure and this just because you pump these in, pressure because you pump these in, just because you pump pressure of the pressure of the pressure will change still 2 pressure is blue one is still 1 does blue one is still now inside this green. But what it does mean is that now it does mean is green now single adding these two is 3 adding partial pressure partial pressure total pressure added together so that kind of brings us to what mathematical Dalton's law. So right now let's start talking about that. Now let's start talking about that. So I've got a piece of your subscript here. Total is equal to star. I've got a piece of your star. What I want you to do is, what I want you to do, find R, and what I want you to do is 30 gas all of its and this question, 30 seconds. This question, spend 1 minute, spend 1 minute, 3 minutes, 5 minutes, to solve this, 3 minutes, to solve this, the person who's sitting next to me, I'm actually going to stop, and I'm actually going to stop these answering. The reason why I was saying, because that helps us answer our next question. Liters, so this number, liters, ATO, moles, Okay, so I'm going to go through this now. So usually when you really go through this, usually when you really have things, you got to usually when you really have these portraits, they are regular. So the pressure. So the pressure that answers the volume. That answers so the volume. The volume is liters, and has the volume, and has liters and temperature. So we're going to temperature and temperature is Kelvin, right hand side. So just like now that we have all this information. Now that we have all this information, we have our equation. Now that we have all this information, we're going to have a problem. So I'm going to stop this equation. So I'm going to stop this mission. Next, we're going to go to the next one. So I'm going to stop this video and we're going to go to the next one, and you're going to flip your paper over. We're going to divide. And so the pressure, neon is 15.2 ATM. Okay, so first of all, we do want to put both of these numbers in significant figures. Both of these numbers in significant figures. 3 is the magic number. Looks like 3 is the magic number. So it's got to go to 15.3. It's got to go to 15.3. Okay, so you've got a lot of answers you need to bubble in. So you've got a lot of answers you need to bubble in here. This one, we're going to circle pressure of oxygen, and it is important to point out that oxygen. It is important to point out that this was the pressure of oxygen. This is the pressure neon. And then the last question was I still need the pressure total. And this is where Dalton's law of partial pressure. If we can find the pressure of each individual gas, say that 4.61 ATM plus 4.61 ATM plus 15.3 ATM is going to total pressure. The total pressure. So the total pressure is going to be 19. The total pressure is going to be 19.9.1 ATM. And if we want to put that into significant figures, into significant 19.9, we're going to put 19.9 is the total ATM is pressure. The total P total pressure. P total. And so before we finish this up, you move on to practice, let's go look back at this question and think about how did I know to do this? How did I know to do this? How did I know to split into oxygen? So 30 seconds thinking to yourself. What were some hints that told you? What were some hints that you were going to have to do this type of setup? You were going to have to do. We found the pressure of each of these gases. We found the added pressure of each of these gases and then added them together. So what were some hints in this question? What were some hints in this question that told you we were going to have to do this? So what I saw was, that's a big one. You've got two gases. That's a big one. There's two gases. So you're clearly find the pressure. You're gonna have to find the pressure of each. It spells it out for you in this question. What are the pressures of each? What's the total? What are the pressures of each? What's the total pressure? And unlike the last example, which is a little bit simple, we didn't have the pressures. So we had to use other information. So we had to use the other information to find it. Things got a little more complex here. You have problem set. Similar to this problem set, some simpler ones to this problem, to solve, some simpler ones as well. At the end of class, you may work with the person at the end of class next to, but you may not get up next to, but you may not get up. Substitute has the substitute has. So get started. It is due at the end of class. So get started. It is due at the end of class.